Hello, class, and welcome to the sample problems for Chapter 9, problems 5 through 8. Um, so here we've got Thunderbolt Incorporated, and they manufacture motorcycles. They've recently adopted absorption costing, and they're trying to decide which denominator level concept they should use for allocating out their fixed overhead to their units of production. Um, so they sell the motorcycles for an average price of 8,200. Their budgeted manufacturing overhead costs are estimated at $6,480,000. So I'm just gonna make a note here, 6480. There we go. And so that's the amount that we have to allocate out. And they're asking us to calculate out the overhead allocation rates at using four different methodologies. Okay, so looking at this, we've got theoretical capacity, which is based on 3 shifts, completion of 5 motorcycles per shift, and a 360-day year. So theoretical capacity of 5,400 units here. So that gets us to $1,200 per unit. And so no rocket science here, right? Just taking this and figuring out like, hey, if this is our max that we can do, what rate should we be allocating this out at per unit? Okay, so we're going to do the same thing here. For part B, practical capacity is adjusted for unavoidable interruptions, breakdowns, and whatnot. So practical capacity, we see here, instead of 5 motorcycles per shift, it looks like they're doing 4 per shift and 320 days a year instead of 360. So that's getting them 3,840. So let's see here, 1687.50. All right, and then for normal capacity, they're providing us this one, 3,240 units, and then 3,600 units for master budget capacity. So again, if we just divide those out, that gets us to $2,000 per unit and 1,800 per unit. All right, plug these on in. So really, like the math here is not super hard. It's just understanding if you're given a set of facts, which ones would be associated with theoretical, practical, normal versus master budget. Let's see. So looking at what are the benefits of using either theoretical capacity or practical capacity for this, right? So theoretical would be like maximum number of potential units we could produce, right? We see here that that gets us the lowest rate here. Now, what's different about those two fundamentally from the other two is that they're not considering demand. They're considering just like how much we can crank out here. So variances that arise from the use of theoretical or practical concepts will signal that there is a divergence between the supply of capacity and the demand for capacity. So that information is useful for managers to know. As a general rule, however, it is important not to place too much reliance on the production volume variance as a measure of the economic costs of unused capacity. So that production volume variance, right? The difference between what we budgeted out for our overhead versus what we allocated out is telling us when there's a difference between um, um, or if we're not allocating it all out, it's because there's a difference between what we were capable of using and what we actually ended up using and allocating, right? Okay. So for the next question here, we've got a cost-based pricing system. What are the negative aspects of a master budget denominator level, and what are the positive aspects? Well, okay, so what are the negative aspects of the master budget denomination level? Well, if we're using, so a cost-based pricing system, that's where we take what does it cost us to produce the item, and we mark it up by a percentage or a dollar amount to arrive at our ending price. Okay. Um, so if thinking about like allocating overhead, right? Um, if we're using the master budget one, then we're going to be allocating out our fixed overhead costs in terms of what we believe that we will put out there, right? So if our demand is lower than expected, um, or if we have a low demand associated with our budget, then it's going to be fewer units that will get allocated out to. So that will be more per unit that will get allocated out. So that means that we will have high prices when demand is low. Conversely, it will lead to lower prices if the demand is high. And that is called a downward demand spiral, basically. So thinking about that, right? If demand is low and you raise prices, you make it more expensive for people to buy things, which makes your product even less desirable, which means that it will become even lower demand, right? On the other hand, if the demand is super high and you're allocating it out based on a larger expected number of units to be sold, then you're going to be allocating out less fixed overhead per unit. If you do cost plus, the ultimate price that you're charging is going to be lower. So you're actually going to be lowering your prices when your demand goes up, which is counterintuitive from like a basic economics standpoint, right? Because you're basically going to drive even higher demand when you'd really rather reduce the demand and get a higher price per unit if you possibly can do so, right? The positive aspects are that it is based on the demand for product, and it indicates the price at which all your costs would be, um, all costs per unit would get recovered to enable the company to make a profit, right? So you know that everything will get allocated out and still make a profit under cost plus pricing with a master budget denominator, assuming that your master budgeting is accurate. Okay, so for problem number 6 here, we're going to walk through a simulation of what this looks like in terms of generating operating income for these 4 different capacity types. All right, so we've got energy glow light, and they produce energy efficient bulbs, and we're expecting that demand is going to increase markedly over the next decade. So there's high fixed costs with this company, so they're going to use absorption costing, and their production volume variance is written off to cost of goods sold, just like we did in our earlier problem number 2. Variable cost of production is $2.70 per bulb. Okay, so let's just put this variable cost, $2.70 per bulb. Fixed costs are $1,020,000 per year. Okay. Variable and fixed selling and administrative expenses are 20 cents per bulb sold and 290,000. Okay. And the bulbs can sell for $9.60 each. Okay, so let's look at our capacity information here. Okay, so we've got theoretical capacity here. I'm just gonna, maybe I don't want that right there. So 850,000 bulbs, and here are 425,000, 272,000, and 212,500. Okay, so label that. And okay, so we have So the first thing they're asking us to do is to calculate the inventoriable cost per unit using the level of capacity, right? So with this, we're going to figure we're only inventorying our manufacturing costs here, right? For uh, um, for our absorption costing. Sorry, I got like stuck on that word absorption for a second. Okay, so we've got our variable costs here, right? And then we need to know what our fixed costs are. So if we have a capacity of 850,000, we're going to calculate out they want us to come up with, we're going to have fixed costs, fixed manufacturing overhead per unit. We need to come up with that. And then we are going to add in our variable production cost per unit, which we already know is 270 for each of these. So to get the fixed manufacturing overhead, we're just going to take that fixed manufacturing cost of 1,020,000 per year and divide it out based on our capacity. So oops, 850,000. Actually, you know what I'm going to do here? Let's do this. Let's put that up at the top and we can link to it. So equals D1 divided by D3 there. Okay, so that's going to get us then 120 plus 270 is going to be total of 390, right? Okay, so we can actually fill in all of these ones. We know that this variable cost per unit is the same under all of them. It's just going to be a difference in what we assign for the fixed manufacturing overhead here. So actually, I'm going to do this. I got the same thing here. And let's sum that up. So that's going to get us 510. And then let's just copy this down here and do the same thing again. And let's do it here too. Okay, so it's doing the exact same formula here. Just taking this practical capacity divided by the total fixed overhead amount. That's still B, but that one is B. There we go. All right, so here we've got 240, 375, and 480. Okay. All right, so that's our first section for this one. All right, so now they want us to look at what is the production volume variance. So we're going to take that budgeted amount of our fixed manufacturing overhead and we're going to subtract out what would be allocated here using the budgeted cost per output unit that is for allowed actual output produced here. Okay, so the first one. Okay, so our budgeted amount is the same. That's the 1,020,000. And then here, let's see. So we actually produce 250,000 bulbs. So we're going to take that amount and we're going to multiply it times 250,000 bulbs. So I'm going to take my rate, $E, $1. So that's going to get us to, let's see, wait. Oh, sorry, I need my fixed rate here, not my total rate. Got a little ahead of myself. D5 there. There we go. So this is my fixed cost rate times number of units, which is the 250,000 here. So if I take that formula, oh shoot, and I don't have room here for that. So let's just do this. There, now I'll have room for all of them. All right, so this is the amount that ends up getting allocated out for each of these rates. Okay, and then the difference between the two of them is going to be just what over or under allocation here. So 720,000 and 420,000. I'll do 82,500 and 1,200,000. Okay, and then remembering that we always put these in here as a positive. Okay, so is it favorable or unfavorable? Well, if we allocate out less, we're under allocating, therefore it is unfavorable. So under allocated, unfavorable, again, under allocated, again, the amount allocated is less, so under allocated. And then here, we are allocating out more, so that one is going to be favorable. Okay. Oh, really? That's not what I wanted to do. There we go. I just want to get up here so you all could see that for a second. Okay, so the last thing they want us to do, we're assuming there's no beginning inventory, actual sales of 212,500 bulbs. So now we're going to calculate our operating income here. So they've given us all of our headings here, so at least we don't have to bother with that. So now we just need to do our revenue. So if we are selling these at $9.60 per bulb, then we are going to be, and they said we are selling 212,500. That gets us 2,040,000. So, and that's going to be the same amount for all of these, right? So now though, we need to take the inventoriable cost times the number of units that are sold here to get our cost of goods sold. So we got to go back up. So we had an inventoriable, our totals that we calculated were the total inventoriable cost. So we're going to take that times the 212,500. And that's going to get us 828,750. So that's going to get us, let's see. So, and then the production volume variance, we already calculated. So it's 720,000, which is unfavorable. So we're going to treat it like it's an expense, right? So we're adding in that additional amount that did not get sent over to inventory. So looking at the math here, that's going to get us to 491,250. And then our variable selling costs are Variable selling cost is 20 cents per bulb there. Okay. So that's going to be 0.2 times. Yeah, so I'm going to do this. I'm going to put 0.2 and I'm going to put here, leave that for now. So 20 cents per bulb. And I am going to put that as a minus. The fixed selling costs were 290,000. They gave us that amount. So then we're going to take these and sum them up. And that gets us to 158,750. All right, so same drill here. Sales are going to be exactly the same for all of these, but our cost of goods sold then are going to be let me just scroll down here. I'm going to move all this down so I can put a formula here. So 2,040,000. Cost of goods sold we had was the 390. So over here, we're going to take 212,500 times our 510 and copy these over. Copy these over too, and then I'm just going to edit this for the correct. So 645 and 750. So I'm changing the costs so that it's calculating those correctly for each of those. Okay, so then production volume variance is 420,000. Here was 720,000. So let me just copy those other ones over here too. Gross margin. And then we've got our variable selling, fixed selling, and operating income. Okay, so our gross margin then is just going to be the revenue minus the cost of goods sold and the production volume variance. And I'm going to make sure, since this is going the opposite direction, I want to do that. So subtracting a negative is the same thing as adding a positive. So let's go ahead and do that there. So now we've got our gross margin all the way across the board. Our variable selling costs are going to be exactly the same because it's 20 cents per unit and it's the same number of units all the way across the board. This is going to be the same too. And then this one I can copy right over as well. So working smarter, not harder. All right, so 420,000 unfavorable. All right, so literally I'm just plugging all these in now. And last one, finally. Okay, all right, so that gets us through number 6. All right, we're getting there, right? Okay, so there's not quite so many calculations in this. This number 7's the last one where we've got a big calculation in it here. So we'll move on to number 7. Okay, so for number 7, we've got no more litter incorporated. And they have recently patented a new electronic and remote controlled litter box. So that sounds exciting. Research indicates that the scooping of the litter is the task that most cat owners hate. And their new product automatically scoops and fills the pan with fresh litter from the reservoir. They've budgeted 40,000 units for production and sales in the first year of operation with a practical capacity of 60,000 units. They're providing us with their variable costs per unit. And looking at that here, let's take a look. What do we got? Make this a little bigger. Okay, so practical capacity. I'm just going to put this. Okay. All right, so materials 15, labor 32, and overhead 18. All right. Nothing crazy going on here. Okay, so these are on a per unit basis and they want, oh, fixed overhead. Let's put that up here too. Fixed overhead is 450,000 units. Okay, so so assuming we use absorption costing, what is the formula to compute our selling price? Okay, well, if we're using absorption costing and we're using a master budget utilization as our denominator level for our fixed overhead rate. Okay, so let's calculate our rate here. And we're going to do it based on budgeted units since they're using the master budget utilization. So $450,000 divided by 40,000 units, that's our fixed overhead rate that they're going to charge per unit, okay? Of 1125. So that's going to get us a total cost here. Adding those other costs, materials, labor, overhead, and the fixed overhead per unit. So these are the variable costs, right? So this is variable overhead. This is fixed overhead. Just to differentiate why we have overhead on there twice, okay? So that's going to get us a total cost for those units of 76.25. Now our sales price, so if we're doing cost plus pricing and they're doing 150%, then we are going to take our manufacturing cost per unit and we're going to multiply it times the percentage of manufacturing cost. Okay, so not just the overhead cost, but the total manufacturing cost per unit. So this is our manufacturing per unit here. And so our sales price is going to be 76.25 times 150%, so which is equal to 1.5. So that gets us 114, if we round it to the nearest penny, 114.38 for the price. Okay. Now, due to a lagging economy, sales are not as robust as we anticipated, adding to the pressure on sales. We believe the stream of newcomers to the market are using our patented protected tech, or newcomers using patent protected technology, and they're pricing their products at a loss. No changes made to the pricing model and budgeted sales, and production for 2021 is 30,000 units. So before we had 40,000 units. So remember what we were just talking about as far as like absorption costing and using your master budget amount to allocate that out. If we then budget fewer units, what would happen to our rate? We would end up charging $15 here, right? So then we're looking at So then we are looking at $80, right? And then if that's what we're using, 80 times 150% means we'd actually increase our price when our demand is going down. So remember that concept of the demand spiral? We would have a new selling price that would actually go up despite our demand going down, which is kind of contrary to what you want to do in terms of like understanding, right? When demand goes up, then pricing can go up. But when demand goes down, you want to sell stuff. So you should theoretically be decreasing your prices, right? So by using this budgeted units produced and not our practical capacity, we are burdening our products with the cost of the unused capacity. The competitor has not done this. They've done the opposite. And with our higher selling price, our sales have gone down. Consequently, our budgeted quantities are going to be even lower, which is going to increase the unit cost and selling price even more. So that is, as I said, a downward demand spiral, and it causes us to continually inflate our selling price, which leads to progressively lower sales over time. Okay, so now they're saying, let's recompute this using our demand pricing as the denominator here. So let's go here. The rate, if we do it over here, taking our 450,000 divided by the 60,000 units gets us $7.50, almost half as much per unit to allocate that out, which means that we would have 72.50 for cost, and that would get us 108.75 for our new selling price. Okay. So it's important to understand how those other denominators are going to influence your pricing if you're using cost plus pricing. The alternative, you could also switch from using cost plus pricing to another pricing method potentially, but let's see. So if we had used practical capacity as our denominator level of activity, our initial selling price would have been lower than what we calculated up above, right? So 108.75 is lower than 114.38, and it probably would have resulted in higher sales with the lower price. Using our practical capacity will result in a let's see. So thinking about that though, right? Like in our production volume variance, so we would be allocating out fewer, right? So or less. So we're allocating out a lower amount per unit, which if we end up allocating that out based on units sold, that would be a larger production volume variance or higher unfavorable production volume variance. And then we would end up writing that off to cost of goods sold, which would also reduce our operating income. Yeah. So either way, it ends up eventually in operating income. But when you have the production volume variance as unfavorable, then it gets in there as a lump sum, which could mean that you would potentially have a lower amount because you're probably otherwise, if you allocated it correctly, then some of that would probably be still sitting in your inventory, in your inventory units. Okay, so that gets us to our last problem here, which is a word problem. So what are factors that influence a break-even point under variable costing and absorption costing? Well, thinking about your break-even point, right? Your break-even point is the point where your um, contribution margin total is equal to, so your contribution margin is equal to your fixed costs, which results in zero operating income, right? So what would influence your contribution margin? Well, your contribution margin, well, yeah, so contribution margin influences it. We got that as an answer here, B, and then your fixed costs would influence that as well. So both of those. Um, would your production level influence that? No, because how many you make has nothing to do with how many you sell. So it's not going to, your production level isn't going to necessarily influence your revenues. Let's see, would your denominator level chosen to set your fixed manufacturing cost rate influence it? Also no, because under this formula, your fixed costs are all of your fixed costs. So in this one, under variable costing, where you're using the revenue minus um, variable costs gets you, oh, come on, gets you to contribution margin minus your fixed costs gets you to your operating income. Production level and denominator level do not affect it. Okay, now under absorption costing, however, your production level affects your allocation, which affects your production volume variance, right? And also your denominator level chosen determines your rate, which determines what you allocate out. So that would also affect it. And then why do both of those affect it? Because what you allocate out isn't necessarily what ends up in your break even is going to be due to what you sell. So your contribution margin per unit will always affect your break even point, right? Because that includes your revenues, affects your break even point. So does your variable costs, and then also your total fixed costs, which are used to calculate your rate. So all of those factors will affect your break even point under absorption costing. All right, that is a wrap up for the chapter 9 problems.